Hi friends, welcome to my channel Yours Educare Planet. Recently I have prepared one video how to bring the Solver Microsoft Excel add-in on the ribbon of the Microsoft Excel. Usually this add-in is not available. We have to bring this add-in on the ribbon of Microsoft Excel. It is very easy process. The link of the video how to bring the Solver add-in on the Microsoft Excel ribbon is available in the description of this video. Please see this video and bring the Solver add-in on the main ribbon of Microsoft Excel. So today I'll let you know how to use Solver to find out the arbitrary constant of complex equation. So this task I will take up today. Let us fit the equation using Solver. As I told you, to fit the equation using Solver, what is the foremost requirement? Requirement is you must know the fitting equation in advance. That is the foremost requirement. If you do not know the fit equation to whom you want to fit your data, you cannot use the Solver to find out the arbitrary optimum value of the arbitrary constants. So here I know the fitting equation. So here the fitting equation. So this is our fitting equation. Ft is equal to y naught a1 exponential minus x minus x naught upon t1, a2 exponential x minus x naught t2, and x naught, x1, a1, t1, t2 and a2 are our arbitrary constant. Here these values which you can see on my screen are the optimum value which I had already obtained using the Solver. But initially what we can do, we can give them these values equal to 1. Say I use y naught as 1, x naught as 1, a1 1, t1 1, a2 1, and finally t2 is equal to 1. These values 1 1 are our random guess. So if you know the initial guess, that is more appropriate to use the Solver. So first requirement is you must know the fitting equation, and to in a fitting equation use all arbitrary constants, say is equal to 1. If you know the initial guess of these parameters, you can use that value in it. However, we have a method to choose the initial guess. I will let you know just later. Okay, then what is the next step? Next step, once you create equation in Excel, okay, we have a value that is corresponding to our dependent variable, right? Y fit is the value which I have obtained using this equation. Okay, then next step is to take the residual. What is residual? Residual is the difference between y fit and y. Simple. Residual is difference y fit minus y, or you can say y minus y fit. It doesn't make any difference, because in next column, in E column, you can see SR. SR stands for square of residual. Square of residual. I will take the difference, and here I have take the square of the residual. Okay. So this is the Y fit. First C column, in D column I have a residual, and in E column I have a square of residual. Finally, you can see the bold column. This is called SSR, sum of square of residual. We call sum of square of residual. Okay, we called it SSR, right? So finally I will take the sum of all these SR and we called SSR. This is also our objective cell. Okay, we have to minimize it. We have to minimize it. Okay, so we have 3 steps. First, we have to create a fitting equation in Excel. then I will take a difference between the fitted value and the actual value. Okay, we call it a residual. Then I take the sum of square of residual and finally sum of square of residual. You can see here, I can use a different pen, red one. These are the two plot you can see here. I just enlarge it. Okay, you can see here these points are the actual points, actual data, and these yellow are the fitted data. You can see here fitted data. So you can see these data are almost matches with the actual value. So this is the plot I have obtained using same equation fitted in origin. So I can see this plot and that plot almost the results are almost same. I'm not saying exactly same, but solver can do the job as origin is do for us. But origin is a paid software and Excel is a free software. I can show you. The actual process. Here is X parameter, which is our independent parameter. This is the Y parameter, which is independent data. I have entered the data in the first two column. Here is the equation. You can see this equation. You just note down. I can also mention this equation in description also for you to try the same with same data. Okay, so here is the equation which I have created in Excel using very simple commands, very simple $sign and nothing else. So if you know this equation, how to create the equation in Excel, how to create a formula in Excel, that is good. If not, I will prepare one video for you to understand how we can create the equation in Excel. So in this equation you can see all these constants y0, x0 are involved. So initially you can note down the value is 3.96. This is SSR, and now I am giving them value 1. Right now this is my guess, but if you know the initial guess, say I use this 0.5 for example, you can see here this data is going further separated from my actual value. So I'm going to take it 0.06 for example. This data is going also away from. So it means instead of using 0. I can use 2.5 for example. You can see data is going close to that one. Also instead of taking 0.5, I can use 1.2 for example. You can see data is approaching to the actual data. So this is what I told you. If you initially know the guess of these parameters, it would be better for the solver to solve in a more optimal manner. So now what we will do, as I suggest you, I have to minimize this one. Now I'm going to use the solver. So I go to data. In data I have a solver. In solver, the cell, let us remove first of all. This one is our objective cell, right? I have to minimize it. Now by changing the variables, I am removing the variables. Now I am taking the variables. So these are the variable. I am not using any constraint because my equation is not a linear. I are using the GRG non-linear. Do not take this make unconstrained because I have not entered any constraint here. Just leave all these setting first of all. Let's go for solver. I can use the answer also in report. Keep solver solution. Okay. You can see here. Initial it was 201. Formerly it was 500. Then I used the some parameter. Then it has come to 3.9. You can see all these parameters are obtained. Optimum value, and now you can see these two plots are very much overlapped with each other. It means actual data and fitted data are almost matches, except at one point, that is 1.49. Sometimes it happens because it depends upon the equations. So you can see this plot is from origin and this plot from solver. Almost we obtained a similar result from solver as we have obtained from the origin pro. So this is the way how we can use the solver to find out the arbitrary constant of any equation